So in this video, we will try to solve another problem. Previous year KTU problems. This was asked for civil engineering in S3, MOS subject. This is from module 5, torsion. Okay, so module 5, in module 5, the torsion area is that this question. It was asked in 2020 December for 6 marks. So the question is, solid circular shaft is required to transmit 25 kilowatt power at 250 rpm. The maximum torque may be 1.5 times the mean torque. The shear stress in the shaft should not exceed 40 Newton per mm square and the twist 1 degree per meter length. Determine the diameter of the shaft. Take modulus of rigidity 18 kilonewton per millimeter square. So remember this. This is we have done a problem similar to this on one of the previous video. So we will just solve this very fast. So let's give the given write the given data. What are the given data? So power to be transmitted is 245 kilowatt. That means 245 into 1000 watts. The RPM is 250 rotations per minute. Then maximum torque may be 1.5 times the, so T max will be equal to 1.5 times T mean. Okay. The shear stress in the shaft should not exceed. So tau max is nothing but 40 MPa. So 1 Newton per mm square is 1 MPa. You should remember this. Okay. Then they have given twist per unit length is 1 degree. So that means theta upon L is given as 1 degree. So it is same as pi by 180 radians. So theta by L, twist per unit length. Okay. So I think the previous question which I have done, they have given the length also, twist and length separately. So now we had to do theta by L to find the twist per unit length. Determine the diameter of the shaft. If the modulus of rigidity G is 80 kilonewton, so that means 80 into 1000 Newton per mm square. It is same as 80 into 1000 MPa. Okay, so you have to find the diameter of the shaft. It's a solid shaft. It's a solid shaft. So we have to find the diameter. So this is the conditions. So basically, the moment you hear power, you can write the power equation. Power is given by 2 pi n T upon 60. So again, always remember, here torque is given in Newton meter, and here power will be in watts, and N will be in rotations per minute. Sometimes they can confuse you and give rotations per hour or rotation per second. Then you cannot use this. You have to convert into rotation per minute. Okay. So that variation is not at come. It can come on a later exam. So we have power. We can find the T. So in this equation, the actual T is nothing but, this T is nothing but mean torque, Tm. Okay, this is Tm, mean torque. So mean torque, I will represent it properly. I will write Tm. Okay, right. So let's substitute to get the values. So quickly, 245. So again, torque is T, mean torque is nothing but P times 60 divided by 2 by n. So this is nothing but 245 into 1000. 245 into 1000 is the torque in watts, into 60 divided by 2 into what is the value of pi? Sorry, 2 into pi into so this, if I substitute the values here, what you will get is 245 times 1000 times 60 divided by 2 pi into n. What is n? 250. So this gives me, so let's just calculate this very fast. 245 times 1000 times 60 divided by 2 times pi times 250. So this is 9358. Okay, 9358 Newton meter. This is the mean torque. So if you go with the maximum torque, is 1.5 times mean torque is 1.5 times 9358, which comes out to be, so this times 1.5 gives 14037 14037 Newton meter. Okay, in this we got the maximum torque. Now what we will use the second equation, torsion equation. T by J equal to tau max upon capital R equal to G theta upon L. Okay, now in this equation you have to always remember T should be in Newton millimeter, J should be in millimeter raised to 4, tau and G both should be in MPa, R should be in millimeters, theta should be in radians, and L should be in millimeter. Okay, I hope you will remember this. Now we just have to use this equation two times. We'll use these two to find one value of T, and we'll use these two to find another value of T. Okay, so first what we'll use T by J will be equal to tau max upon R. Now here R is nothing but capital D by 2. Okay, so D we don't know, and J is nothing but pi by 16 into D to the power 4. Sorry, pi by 32. Pi by 32 into D to the power of 4. Right? So this we just have to substitute. So T equal to tau max into J. What will be J? Pi by 32 into D to the power 4 into, so 1 by R is 2 by D. So this gives me tau max into pi into D cube by 16. D and D get cancelled. 2 and 32 will become 16. Okay, so we can substitute. Tau max is what? Tau max is given as 40. Pi into D, we have to find the D cube divided by 16. So this should be equal to torsion. The torsion which we have found is 14037. Remember, it should be 14037 into 10 to the power 3. So my D equal to 16 into 14037 into 1000. Because this is Newton meter, I am converting to Newton millimeter. Okay, divided by 40 pi raised to 1 by 3. Right? So 16 into 14037 into 10 to the power 3 divided by 40 pi. So this will come out to be, so if I take up the calculator and calculate this quickly, so this comes out to be 16 times 14037 times 1000 divided by 40 times pi. Okay, now we have to find cube root of the answer. Give me 121.35. So this is 121.35 mm is the diameter that is required. So this is the first part that we are solving. Now we can so this diameter. So what it is telling is with this diameter, the given torsion is 14037. So when we apply this much torsion on this diameter shaft, the maximum shear will be 40 MPa. It will reach that value. Okay. Now we have to find at what torsion or at what diameter. If you apply this torsion, we will get a theta by L of pi by 180. So to solve this, we'll take up the next part. So let's take the next part. The second part of the equation. So that means T by J equal to G theta upon L. So yes, substitute it here. Now we know that J equal to T L. Okay. Now we can substitute the values here. uh, T equal to J into G theta upon L. So J is 5 by 32 into D to the power 4, and G is given. G is given us, we have given the value of G is 80 into 1000. So 80 into 1000 times theta by L is already given, it is pi by 180. Pi by 180. This will be equal to T. The value of T is, as we have already calculated, 14037 into 10 to the power 3. Okay, so from this we can calculate the value of D. D equal to 14037 times 1000 times 32 times 180 divided by, so this pi and this pi will become pi square, then 80 times 1000, this raised to 1 by 4. Okay, this is the value of D. Now we'll solve this. So before that, I think I can cancel this and this. So this gives me, so I'll clear this and I'll start solving. So 14037 times 32 times 180 divided by pi square times 80. Okay, so this is 102401. Now I will find the fourth root. Fourth root of the answer will give me 17.88. Okay, so this is a very small diameter that we are getting, 17.88 mm. Okay, so this is the smaller diameter that I am getting. So the question is which diameter we have to take. So you can see here in this equation, when diameter is more, the value of J will be more. When the value of J will be more, the theta value will be less. Okay, so if the diameter is more, we will get less theta by L. So that is acceptable. The theta by L maximum value should be 1 degree. So if we increase the value of diameter, the value of J will automatically increase. So automatically the value of theta by L will be less than 1 degree. So we have to use this 121. So consider 125 mm. So keep it a round figure. We are actually constructing this. So 120, you can give 122 also. So let's say you can say 125 mm because it is a round figure, right? So this is the answer. I hope you have understood this. This was an easy problem. I think it is clearly explained. Thank you. We will solve another problem in the next video. Thank you.